The universe is full of dead worlds, silent, still, their atmospheres stripped away like skin, their surfaces scarred and frozen, bearing the marks of impacts that ended everything that ever lived there. And it is never an accident. For billions of years, the cosmos has been throwing stones, some no larger than a pebble, some the size of mountains, some large enough to crack a planet open like an egg. Earth has been hit before, many times, and each time life has had to crawl back from the edge, rebuild from ashes, begin again. We like to think we are safe here, that the ground beneath us is permanent, that the sky above us is empty except for stars and clouds and the occasional passing bird. But the sky is not empty. It never has been. It is full of motion, full of history, full of things that do not care about us. Every day, countless objects pass near our world. Most burn up in the atmosphere, harmless streaks of light that we call shooting stars. We make wishes on them. We don't know that we are watching the universe exhale, but some survive. Some come closer than they should, and some, a very few, change everything. You might not know it, but as recently as 2023, something passed us by, something we didn't see coming, something large enough that, had its path been just a little different, you would not be here right now, listening to this, breathing, wondering. It came from the direction of the sun, from the one place we cannot look, from the blinding glare of our own star, which hides everything behind it. And we only knew it was there after it had already gone. We call them near misses, but that word is too gentle, too soft. It suggests a game, a close call, a lucky break. The universe does not play games. It does not care about luck. It simply moves, and we are either in the way or we are not. Tonight, we are drifting into the dark universe, into the shadows between worlds, into the stories of the ones that nearly erased us, and the ones that still might. We will look at the scars on our planet, the craters, the forests flattened in an instant, the cities that almost weren't. We will meet the objects that came too close, the ones that got away, and the ones still out there, waiting. But before we drift too far, if this journey stirs something in you, if the quiet, chilling question of how fragile we truly are, of how thin the line is between everything and nothing, sparks a flicker of wonder deep in your chest, consider subscribing to Calm Cosmic Drift. Because this community is built for curious minds like yours to wander, to question, and to find a moment of peace in the vastness of it all. But for now, let's settle in. Find a comfortable space. Let the noise of the day begin to wash away. Relax your shoulders. Take a slow, deep breath. This is your time to drift, to let the universe's quietest questions gently carry you along. Now, let's begin the journey properly. Let's start with something that might surprise you. Part 1. The hidden threat. Every day, about 100 tons of cosmic material enters Earth's atmosphere. That is roughly the weight of a blue whale falling from space every single day. Most of it is dust. Tiny particles, no larger than a grain of sand, that burn up harmlessly as shooting stars. On a clear night, you might see a few every hour. They are the universe's quietest messengers, vanishing in an instant. But there is another category, larger objects, ones that survive the fiery descent and reach the ground. And then there are the ones larger still, objects capable of causing damage, even devastation. These are the ones that concern planetary scientists. Now, here is where the story becomes a little unsettling. We like to think that we can see everything coming. We have telescopes scanning the skies. We have automated surveys designed to detect anything that might pose a threat. But the reality is more complicated. The greatest blind spot in our asteroid detection system is, ironically, the Sun itself. Any object approaching Earth from the direction of our star is essentially invisible to ground-based telescopes. The glare is simply too bright. It is like trying to spot a firefly hovering near a stadium floodlight. The firefly might be there, but you will never see it. This is not a theoretical concern. In 2013, an asteroid approximately 60 feet across entered Earth's atmosphere over Chelyabinsk, Russia. It exploded at an altitude of about 18 miles, releasing energy equivalent to roughly 500 kilotons of TNT. That is about 30 times the energy of the Hiroshima bomb. Imagine 30 atomic bombs detonating simultaneously above a single city. That is what happened over Chelyabinsk. The shockwave shattered windows across 6 cities. Nearly 1,500 people were injured, primarily by flying glass. The explosion was so bright that it temporarily blinded people who were looking out their windows. Some suffered severe sunburns from the intense flash, and nobody saw it coming. The asteroid approached from the direction of the Sun. It was detected only after it had already exploded. Scientists later reconstructed its trajectory from infrasound data and security camera footage. They estimated that it had been traveling through space for millions of years before its final, fiery moment. This event was a wake-up call. And since then, we have learned just how frequent these near misses truly are. Let's stay with this for a moment, because the Chelyabinsk event is worth understanding in greater detail. The asteroid entered the atmosphere at a shallow angle, about 20 degrees above the horizon. Its velocity was approximately 19 kilometers per second, nearly 43,000 miles per hour. To put that into perspective, that is more than 50 times the speed of sound. At that speed, the air in front of it compressed violently, generating temperatures of several thousand degrees, hot enough to melt rock in an instant. The object began to break apart at an altitude of about 30 miles, but the main explosion occurred lower down, around 18 miles above the ground. The shock wave traveled downward at the speed of sound. It reached the city of Chelyabinsk about a minute and a half after the flash. Witnesses described feeling a sudden, intense heat on their faces, followed by a deafening boom that seemed to come from all directions at once. Some thought it was an earthquake. Others thought it was a plane crash. Very few understood what had actually happened. The energy released was equivalent to about 500 kilotons of TNT. To put that into perspective, the atomic bomb dropped on Hiroshima released about 15 kilotons. The Chelyabinsk meteor released roughly 30 times that amount. And yet, no one was killed. The injuries were primarily from broken glass, windows shattered by the shockwave, as people rushed to windows to see what had caused the flash. It was a reminder that the most dangerous part of an airburst event is often not the explosion itself, but the human response to it. But here is the detail that continues to trouble scientists. The Chelyabinsk object was only about 60 feet in diameter. That is relatively small by cosmic standards. The asteroid that created Meteor Crater in Arizona was about 150 feet across. The Tunguska object was about 120 feet across. And the Chicxulub impactor was several miles across. There is a wide range of possible impactors out there, ranging from the size of a car to the size of a mountain. And we have only mapped a small fraction of them. This is the hidden threat. Not the known objects, but the ones we haven't found yet. The ones that approach from the glare of the sun. The ones that are too small to detect until they are already upon us. And that leads us to a deeper question. How many close calls have we already had that we simply didn't know about? The answer, it turns out, is more than we ever imagined. Part 2. The Close Calls. In July 2023, an asteroid named 2023 NT1 passed within approximately 62,000 miles of Earth. To put that into perspective, the Moon orbits at a distance of about 240,000 miles. This object came more than 3 times closer than the Moon. Imagine looking up at the night sky and seeing an object pass between us and our nearest cosmic neighbor. That is how close it came. It was estimated to be about 200 feet in diameter. Not a civilization ender, but large enough to cause significant regional devastation if it had struck a populated area. An asteroid of this size would release energy equivalent to several megatons of TNT. It would level a city. It would kill millions. Here is the detail that gives scientists pause. 2023 NT1 was not detected until 2 days after its closest approach. It came from the direction of the Sun. Just 6 months earlier, in January 2023, an even closer approach occurred. An asteroid designated 2023 AV, roughly 10 to 16 feet in diameter, passed within about 9,000 kilometers of Earth's surface. That is closer than many of our satellites. Satellites that beam our television signals, our phone calls, our internet. This object passed right through that orbital layer. It too approached from the Sun's direction. And then there was 2020 VT4. In November of that year, this small asteroid, estimated to be roughly 15 to 30 feet across, about the size of a bus, passed within just 370 kilometers of Earth's surface. That is lower than the orbit of the International Space Station. Think about that. Astronauts aboard the station, orbiting peacefully above us, could have looked out their windows and seen nothing, because this object was discovered approximately 15 hours after its closest approach. It came from the Sun's direction. Think about that for a moment. An object traveling at 30,000 miles per hour, passing closer to us than the astronauts aboard the space station, and we learned about it only after it had already left. It was like a bullet passing through a room full of people, and no one even knew it had happened. The frequency of these events is increasing, not because more asteroids are coming, but because our detection capabilities are improving. Half of all known near-Earth objects have been discovered in just the last few years. We are, for the first time, truly seeing what surrounds us. And what we are seeing is both fascinating and humbling. Let's look more closely at 2020 VT4 because it represents something of a milestone in near-Earth object detection. This asteroid was not discovered by a professional survey telescope. It was discovered by the Atlas Survey System in Hawaii, which was originally designed to detect comets. The fact that it found an asteroid passing closer than any previously recorded object speaks to the sensitivity of modern surveys, but it also speaks to the scale of what we are missing. Consider this. 2020 VT4 was roughly the size of a bus. If it had struck Earth, it would have caused significant damage in a localized area. It would have created a crater the size of a football field. But it would not have been a global catastrophe. The real concern is for objects much larger, objects that are more difficult to detect precisely because they are further away. The Chelyabinsk event demonstrated that even a relatively small asteroid can cause widespread damage. The Tunguska event demonstrated that a medium-sized asteroid can devastate a region. And the Chicxulub event demonstrated that a large asteroid can cause a mass extinction. So the question becomes, how many Chelyabinsk-sized objects are out there, and how close have they come without us knowing? The answer is, we don't know. But we are beginning to understand just how common these events are. Surveys like Pan-STARRS and the Catalina Sky Survey have dramatically increased our rate of discovery. In the early 2000s, we were discovering a few hundred near-Earth objects per year. Now, we are discovering tens of thousands. The curve is still rising. What this tells us is that the solar system is much more crowded than we once believed. There are millions of objects out there, ranging from tiny dust particles to mountains of rock. Most of them are in stable orbits that never bring them close to Earth. But a significant fraction are in Earth-crossing orbits, and some of those are large enough to cause concern. But to truly understand these near misses, we need to step back, way back, to a time before anyone was watching. Part 3. The Tunguska event. To understand the scale of these near misses, we have to step back a little more than a century. On the morning of June 30th, 1908, something exploded in the skies above a remote region of Siberia known as the Tunguska taiga. The taiga is a vast, unbroken forest. Millions of acres of pine and birch, stretching across the Russian wilderness. It was a place where almost no one lived. Witnesses reported seeing a blue-white fireball streaking across the sky, followed by a flash of light brighter than the sun and a deafening roar. The seismic shock was recorded by observatories across Europe and Asia. For several days afterward, the night sky over much of Europe was unusually bright, as if the sun were setting in the north. People in London could read newspapers at midnight by the glow of the sky. When scientists finally reached the remote region decades later, they found something remarkable. More than 80 million trees had been flattened over an area of nearly 800 square miles. That is roughly the size of Tokyo. The pattern was unmistakable. An explosion in the atmosphere, a blast of energy that radiated outward and leveled everything in its path. And yet, at the epicenter of the blast, the trees were still standing, upright, stripped of their branches, but otherwise intact. They looked like a forest of telephone poles, all pointing toward the sky. This is the signature of an airburst. An object entering the atmosphere at such a steep angle and such high velocity that it detonates before reaching the ground. The explosion occurs above the surface, releasing energy that travels downward as a shock wave. Imagine a bomb detonating in the air instead of on the ground. The destruction spreads outward in a circle, leaving the center relatively untouched. The estimated energy of the Tunguska event? Somewhere between 10 and 15 megatons of TNT. That is approximately 1,000 times the energy of the Hiroshima bomb. Imagine 1,000 Hiroshimas exploding simultaneously over a forest. The object that caused it is believed to have been about 120 feet in diameter, about the length of a Boeing 737. If that same object had struck a populated area, the consequences would have been catastrophic. If it had arrived 4 hours later, the Earth's rotation would have positioned it directly above the city of St. Petersburg. Imagine what would have happened if that explosion had occurred over a city of millions. Instead, it detonated over an uninhabited forest. The asteroid itself was never recovered. It likely vaporized completely in the explosion. And to this day, there is no crater. Only a vast, silent forest, still recovering from one of the most powerful explosions in recorded history. Let's delve deeper into the Tunguska mystery, because it remains one of the most fascinating unsolved events in modern science. In the decades following the explosion, numerous expeditions were sent to the region. The first was led by a Russian mineralogist named Leonid Kulik in 1927. He expected to find a meteorite crater, but instead found the flattened forest and the standing trees at the center. He was baffled. Kulik spent years trying to find fragments of the object, but none were ever recovered. He drained swamps, he dug trenches, he even tried to use magnets to pull fragments from the soil. Nothing. The leading hypothesis today is that the object was a small asteroid or comet that exploded in the atmosphere, vaporizing completely before it could reach the ground. But there are other theories. Some have suggested that it was a fragment of a comet, composed largely of ice, which would explain why no fragments were found. Comets are dirty snowballs. They would have melted or vaporized entirely. Others have suggested that it was a small black hole passing through Earth. Still others have suggested it was an extraterrestrial spacecraft. These fringe theories are not taken seriously by mainstream science, but they illustrate how deeply the Tunguska event captured the public imagination. The reality is that we may never know exactly what caused the Tunguska explosion. The lack of fragments, the remote location, and the passage of time have all made it difficult to determine the object's composition. But what we do know is that an object about the size of a football field exploded above Siberia with the force of a nuclear weapon, and it happened without warning. And Tunguska was not the first time, nor will it be the last. The scars on our planet tell a much older story. Part 4. The Craters of Earth. To grasp the true history of these events, we must look at the scars left behind. Earth has approximately 190 confirmed impact craters. They range in size from a few hundred feet across to more than 100 miles in diameter. And they tell a story that spans billions of years. The most famous of these craters is in Arizona. Meteor Crater, as it is known, is about 4,000 feet across and 500 feet deep. That is deep enough to stack the Statue of Liberty 9 times. It was formed about 50,000 years ago by an object estimated to be roughly 150 feet in diameter. The explosion that created it released energy equivalent to several hundred Hiroshima bombs. The surrounding landscape was reshaped in an instant. Imagine a blast so powerful that it turned rock to dust and threw it miles into the air. That is what happened here. And yet, 50,000 years is the blink of an eye in geological time. It is only 1/1000th of the age of the Earth. In that time, we have built cities and civilizations. We have written history and explored the stars. And we have forgotten how recently the Earth was struck by a force that could destroy everything we have built. Consider the Sudbury Basin in Ontario, Canada. It is the second largest impact crater on Earth, measuring approximately 37 miles across. It was formed nearly 2 billion years ago by an object estimated to be several miles in diameter. To put that into perspective, the entire city of London could fit inside this crater more than 50 times. Consider the Chicxulub crater, buried beneath the Yucatan Peninsula and the Gulf of Mexico. This crater is approximately 93 miles in diameter. It was formed 66 million years ago by an object roughly 6 to 9 miles across. That is about the height of Mount Everest, but traveling at 45,000 miles per hour. That is the impact that ended the age of dinosaurs. It released energy equivalent to billions of Hiroshima bombs. It triggered wildfires that engulfed entire continents, tsunamis that swept across oceans, and a nuclear winter that cooled the planet for decades. It was the closest Earth has come to complete sterilization since life first emerged. And it happened 66 million years ago. It was not an event of ancient mythology. It was an event of modern geology. It was the most recent of the great extinctions. But was it the last? Let's spend some time with the Chicxulub impact, because it fundamentally reshaped the planet. The asteroid that caused it was traveling at about 20 kilometers per second. That is roughly 45,000 miles per hour. To put that into perspective, the fastest bullet travels at about 2,000 miles per hour. This asteroid was more than 20 times faster. When it struck Earth, it created a crater 110 miles in diameter and 20 miles deep. The energy released was equivalent to more than 100 million megatons of TNT. Imagine all the nuclear weapons on Earth exploding at once, multiplied by 1,000. That is the scale of this event. The impact vaporized rock and ejected it into the atmosphere. The debris circled the globe, and some of it re-entered the atmosphere, heating it to the temperature of an oven. This created a global firestorm that burned forests on every continent. It literally cooked the surface of the planet. Then came the tsunamis, waves hundreds of feet high that crashed against coastlines around the world. The oceans themselves were churned by the force of the impact. Marine life was devastated. Then came the darkness. The dust and soot from the fires blocked out the sun, and temperatures plummeted. Photosynthesis ceased. Plants died. The animals that depended on them died. The food chain collapsed. And yet, some life survived. Small mammals, burrowing creatures, and aquatic animals that could withstand the cold managed to endure. They were the ancestors of the species alive today. That is the legacy of the Chicxulub impact. It was both a catastrophic event and a new beginning. The age of mammals began because the age of dinosaurs ended. Now, we must ask ourselves, are we prepared for the next Chicxulub? The answer is complex, but we are beginning to take it seriously, because this was not just one event. Earth has been pushed to the brink many times. Part 5. The Great Extinctions. Let's pause here and consider the bigger picture. Earth has experienced 5 major extinction events in the last 500 million years. Each one wiped out the majority of species on the planet. Each one reshaped the course of evolution. The most severe of these was the Permian-Triassic extinction, approximately 252 million years ago. Known as the Great Dying, it eradicated about 90% of all species. Imagine walking through a forest and seeing 90 out of every 100 species gone. Imagine the silence, the emptiness. The cause is still debated, but evidence points to massive volcanic eruptions in what is now Siberia, which released enormous quantities of carbon dioxide and methane into the atmosphere, triggering catastrophic climate change. The Siberian Traps eruptions released an estimated 3 million cubic kilometers of lava over a period of about 2 million years. That is enough lava to bury the entire United States under a kilometer of rock. The oceans became acidic. The atmosphere became toxic. The planet became nearly uninhabitable for millions of years. It took 5 million years for life to recover. 5 million years of struggle and adaptation and slow rebuilding. Then there was the Triassic-Jurassic extinction, about 200 million years ago, which paved the way for the age of dinosaurs. And the Cretaceous-Paleogene extinction, 66 million years ago, which ended it. These were not isolated events. They were periods of profound planetary transformation, driven by forces both internal and external. And they remind us of a sobering truth. Life on Earth has been pushed to the brink more than once. It has survived, adapted, and evolved anew each time. But the planet itself has been fundamentally changed by each of these events. We live on a world that has been shaped by catastrophe. The land beneath our feet was once molten. The air we breathe was once toxic. The oceans were once acidic. And yet, life persists. But the question remains, what would it take to push it over the edge again? Let's examine the Permian-Triassic extinction in more detail because it offers a cautionary tale. The Siberian Traps eruptions released enormous quantities of greenhouse gases. These gases triggered global warming of about 5 degrees Celsius. That is roughly the same amount of warming we are experiencing today, caused by our own emissions. But it wasn't just the warming that caused the extinction. It was the chain reaction. The warming released methane from the ocean floor, which caused more warming. The warming caused the oceans to stagnate, creating dead zones where nothing could live. The warming caused the atmosphere to become toxic. On land, plants struggled to adapt to the rapid changes. Herbivores starved. Predators starved. Ecosystems collapsed. The extinction was slow, taking thousands of years. But it was relentless. It was a death by 1,000 cuts. The Permian extinction was slower than the Chicxulub impact, but it was far more devastating. It took millions of years for life to recover. And the recovery was not a return to what had been before. Entire groups of animals disappeared forever. New ones took their place. This is the nature of extinction events. They reset the evolutionary clock. They create opportunities for new species to emerge. But they also cause immense suffering and loss. The question for us is, are we causing a sixth mass extinction? Many scientists believe we are. The rate of species loss in the last century has been alarmingly high. Species are disappearing at a rate thousands of times faster than the natural background rate. But unlike previous extinctions, this one is caused by human activity. And that means we have the power to stop it. We can choose a different path. We can protect the diversity of life on this planet. We can be the first species to prevent an extinction rather than cause one. But that is a different story. Let's return to the cosmic threats. Because the near misses have continued. Even as we sleep, even as we learn, even as we build, the stones keep coming. Part 6. The Ones That Got Away. Let's return to the near misses. In 2019, an asteroid designated 2019 OK passed within approximately 43,000 miles of Earth. To put that into perspective, that is about 1/6 of the distance to the Moon. It was estimated to be between 200 and 400 feet in diameter. That is roughly the size of a football stadium. This object was not detected until just hours before its closest approach. Astronomers in Brazil and the United States spotted it independently, and within hours, they had calculated its trajectory. It was going to miss, but by a tiny margin. A margin that was measured in hours. A margin that was measured in the difference between a near miss and a catastrophe. If 2019 OK had struck Earth, it would have released energy equivalent to several megatons of TNT. That is enough to destroy a large city. Imagine New York City, or London, or Tokyo, simply gone. That was the potential. And here is what makes this story particularly striking. 2019 OK was classified as a city killer. It was large enough to cause regional devastation, yet it was discovered only as it was passing. If it had been on a collision course, we would have had no time to react, no time to warn people, no time to do anything except watch. It is the near misses like these that keep planetary scientists awake at night. Not because they are certain of disaster, but because they are uncertain of what they might have missed. In 2025, an asteroid named 2025 RM1 passed within about 100,000 kilometers of Earth. That is roughly 1/4 of the distance to the Moon. This object was estimated to be about 130 feet in diameter, about the length of a blue whale. Again, it approached from a direction that made detection difficult. Again, it was only noticed because of improved survey capabilities. These are not anomalies. They are patterns. The more we look, the more we find. And what we are finding suggests that Earth is constantly being bombarded by objects from space. The difference is that now we are beginning to see them before they arrive. Let's consider the significance of 2019 OK in more detail. This asteroid was discovered by two separate observatories. The Southern Observatory for Near-Earth Asteroid Research in Brazil and the ASAS-SN survey, which is based in Chile. The fact that it was discovered independently suggests that it was not an obscure object. It was bright enough to be spotted by multiple telescopes. Yet it was discovered only hours before its closest approach. Why? Because it was moving fast. and it approached from a direction that was difficult to observe. The object was traveling at about 24 kilometers per second, 54,000 miles per hour. At that speed, it covered the distance from the Moon to Earth in about 4 hours. If it had been on a collision course, we would have had very little time to respond. 4 hours. That is less than the time it takes to fly from New York to London. Now, let's consider what a response might look like. If an asteroid of that size were detected with only hours to spare, there would be no time for deflection. The only option would be evacuation. But evacuation is not possible for a city of millions in just a few hours. The logistics are simply overwhelming. You cannot move millions of people out of harm's way in 4 hours. You cannot organize transportation, shelter, food, water, and medical care in 4 hours. This is why early detection is so crucial. The sooner we know about a potential threat, the more options we have. And that brings us to the topic of planetary defense. But not every near miss is a large asteroid. Sometimes, even smaller ones remind us of our vulnerability. Part 7. The Bolide over California. Let's explore a particularly fascinating event. In April 2025, a bright fireball streaked across the evening sky over California. Witnesses described it as a brilliant blue-green flash, visible for several seconds, followed by a loud rumble that shook windows. People pulled over on highways to watch. Some thought it was a plane crash. Others thought it was a missile. This object was a bolide, a particularly bright meteor that explodes in the atmosphere. It was estimated to be about 10 feet in diameter and to have released energy equivalent to about 5 kilotons of TNT. That is about 1/3 of the Hiroshima bomb. The explosion occurred at an altitude of approximately 20 miles. No debris reached the ground. No one was injured. But the event was captured by satellites, security cameras, and thousands of smartphones. It was studied in detail by scientists from NASA, the European Space Agency, and the Smithsonian Institution. They concluded that the object had originated in the asteroid belt between Mars and Jupiter, and that its trajectory had been altered by Jupiter's gravity. The great planet, our cosmic protector, had redirected this stone toward us. This event is a reminder that the solar system is a dynamic place. Objects do not travel in static orbits. They are nudged, pulled, and redirected by the gravity of planets, by solar radiation, and by collisions with each other. The trajectory of an asteroid can change unpredictably over time. An object that seems safely distant today may become a threat centuries from now. It is this unpredictability that makes planetary defense such a challenge. Let's consider the California bolide in more detail. It was unusual for several reasons. First, it was exceptionally bright. The flash was visible from hundreds of miles away. Second, it produced a sonic boom that was felt across a wide area. Third, it fragmented in a way that produced a spectacular display of light and color. Witnesses described seeing pieces breaking off and creating secondary flashes as they burned up. Scientists used data from infrared satellites to estimate the object's size and composition. They determined that it was likely a stony asteroid, composed primarily of silicate minerals. Its velocity at entry was about 15 kilometers per second. The energy released, 5 kilotons, is equivalent to about 1/3 of the Hiroshima bomb. If the object had been slightly larger, the explosion would have occurred at a lower altitude, causing more damage on the ground. If it had been just a little bigger, it would have shattered windows. If it had been a little bigger still, it could have caused injuries. As it was, the bolide was a spectacular event, but not a dangerous one. It served as a reminder of how frequently these events occur, and how much we still have to learn about the objects that share our orbit. And sometimes, we plan for the worst. We imagine the scenario. We rehearse the response, because we know that preparation is our only defense. Part 8. The Barber's Chair. In the realm of near misses, one name often comes up among astronomers: 2023 PDC. This asteroid was the subject of a hypothetical exercise conducted by NASA and the European Space Agency. In the simulation, 2023 PDC was discovered with a small but significant chance of impacting Earth in 2032. Over the course of the exercise, that probability increased as more observations were collected. The scenario was designed to test the international community's ability to respond to a potential threat. And it revealed something important. We are not helpless. There are strategies. There are technologies being developed. And there is a growing recognition that planetary defense is not science fiction. It is a practical, real-world concern. But the exercise also highlighted a sobering reality. The decisions we would need to make about deflection, about evacuation, about resource allocation would be incredibly difficult. There are no perfect options. There are only trade-offs. This is the nature of the challenge. It is not simply about detecting threats. It is about preparing for them. And the time to prepare is now. Let's examine the 2023 PDC exercise in more detail. The scenario was designed to simulate a real-world detection and response. It began with a simulated asteroid being discovered by the Pan-STARRS survey in Hawaii. Initial observations indicated a 1% chance of impact in 2032. That might not sound like much, but in the world of planetary defense, 1% is a significant threat. Over the following weeks, additional observations increased that probability to 10%. At that point, the international community convened a planning committee to discuss options. The committee included representatives from NASA, ESA, and other space agencies, as well as experts in disaster management and logistics. The options considered included kinetic impact deflection, nuclear deflection, and gravity tractor. Each had its advantages and disadvantages. The kinetic impactor would require a spacecraft to be launched within a few years. The nuclear option would be controversial, but effective. The gravity tractor would be slow but precise. In the end, the committee recommended a combination of approaches. A kinetic impactor would be launched first, followed by a gravity tractor if needed. But the exercise also revealed the limitations of our current capabilities. We do not have a fleet of spacecraft ready to launch. We do not have international agreements on how to respond. And we do not have the infrastructure to evacuate large populations on short notice. The exercise was a sobering reminder that we still have much work to do. It was a rehearsal for a scenario we hope never happens, but it also showed us that we are capable of planning. We are capable of organizing. We are capable of responding. The question is whether we will be ready when the real moment comes. And we are working on it. Right now, as you are listening to this, scientists around the world are building the tools we need. Part 9. What we are doing about it. So, what are we doing? There are several major programs dedicated to detecting and mitigating asteroid threats. NASA's Planetary Defense Coordination Office works with a network of telescopes around the world to identify and track near-Earth objects. This includes the Pan-STARRS survey in Hawaii, the Catalina Sky survey in Arizona, and the NEOWISE Space Telescope. Together, these systems have discovered more than 30,000 near-Earth objects. That is 30,000 stones we know about, 30,000 that we can track, 30,000 that will not surprise us. In 2022, NASA conducted the DART mission, the Double Asteroid Redirection Test. It deliberately crashed a spacecraft into a small asteroid called Dimorphos, successfully altering its orbit around its parent asteroid. This was the first demonstration of kinetic impact deflection, showing that we can, in principle, push an asteroid off course. The spacecraft was about the size of a vending machine. It collided with Dimorphos at a speed of 14,000 miles per hour. The impact shortened Dimorphos's orbit by 33 minutes. That might not sound like much, but it was a significant change. It proved that the concept works. The European Space Agency plans to follow up with the Hera mission, which will study the impact site and the changes to Dimorphos in detail. It will measure the crater, the debris, and the new orbit. It will give us the data we need to refine our techniques. And there are other ideas being explored. Gravity tractors, spacecraft that use their gravitational pull to slowly alter an asteroid's orbit. Imagine a spacecraft hovering next to an asteroid, using its gravity to gently tug it off course over months or years. Laser ablation, using focused beams to vaporize material from an asteroid's surface, creating a thrust that nudges it off course. This is like using a laser to gently push a rock across a table. And, in extreme cases, nuclear deflection. A nuclear explosion near an asteroid could vaporize part of its surface, creating a powerful thrust that pushes it off course. It is a last resort option, but it is available. These technologies are still in their early stages, but they represent a shift in how we think about planetary defense. We are no longer simply observers, watching and waiting. We are beginning to consider how we might act. Let's look more closely at the DART mission, because it was a significant milestone. The spacecraft was launched in November 2021, and it reached its target in September 2022. It collided with Dimorphos at a speed of about 14,000 miles per hour. The impact was successful. Dimorphos's orbit around its parent asteroid, Didymos, was shortened by 33 minutes. This was a significant change, demonstrating that a kinetic impactor can indeed alter an asteroid's trajectory. The success of DART has opened up new possibilities for planetary defense. We now know that we can deflect an asteroid, at least if we have enough warning time. The key is to detect the threat early enough to mount a response. This is why the NEO Surveyor mission, scheduled for launch in 2027, is so important. It will use infrared telescopes to detect near-Earth objects that are hidden by the sun's glare. By filling this gap in our detection capabilities, NEO Surveyor will help us identify potential threats years or decades in advance. The European Space Agency is also developing missions to study near-Earth objects and test deflection technologies. The Hera mission will rendezvous with Dimorphos in 2026 to study the aftermath of the DART impact. This will provide crucial data on the effectiveness of kinetic impact deflection, and there are international collaborations underway to coordinate planetary defense efforts. The United Nations has established an international asteroid warning network to share data and coordinate responses. These efforts represent a significant step forward, but they are only the beginning. And yet, as we build these defenses, we must also reckon with something deeper, something that puts all of this into perspective. Part 10. The Humility of Scale. Here is where we arrive at the more philosophical dimension of this story. We are a species that has survived because of our ability to adapt, to learn, and to solve problems. We have overcome plagues, wars, and famines. We have transformed the surface of our planet to suit our needs. And yet, when we look up at the night sky, we are reminded of something humbling. The universe does not care about us. It does not know we exist. It is not hostile, but it is not kind either. It simply is. The asteroids that cross our path are not malevolent. They are not targeting us. They are following the same laws of physics that govern everything else in the cosmos. They are natural phenomena. But their impacts, when they happen, are profoundly unnatural in their consequences. This is the perspective that Calm Cosmic Drift invites you to consider. We are not the center of the universe. We are not the most important thing in it. We are a small part of a vast and ancient cosmos, one that has been shaped by forces far larger than ourselves. That realization can be unsettling, but it can also be beautiful, because it reminds us that we are part of something extraordinary. We are the universe made conscious. We are the ones who look up and ask questions. We are the ones who wonder. The near misses remind us of our fragility, but they also remind us of our ingenuity. We see the threat, we understand it, and we are doing something about it. Let's reflect on this a bit more deeply. The scale of the universe is almost impossible to comprehend. The nearest star to our Sun is 4 light-years away. That is about 25 trillion miles. To put that into perspective, if you were to drive a car at 60 miles per hour, it would take you more than 40 million years to reach the nearest star. The galaxy we live in contains hundreds of billions of stars, and there are billions of galaxies in the observable universe. The number of stars in the universe is roughly the same as the number of grains of sand on all the beaches on Earth. That is the scale we are dealing with. In the face of that vastness, our planet is a tiny speck. Our concerns, the everyday worries that occupy our minds, are almost laughably small in comparison. The argument you had with a coworker, the stress of your commute, the things you worry about at night. In the grand scheme of the cosmos, they are nothing. And yet, we are capable of contemplating that vastness. We are capable of understanding our place in it. We are capable of acting to protect ourselves from threats. This is the paradox of human existence. We are both insignificant and extraordinary. We are small, but we are conscious. We are fragile, but we are resilient. The near misses that we have experienced remind us of this paradox. They show us how vulnerable we are, but they also show us how much we have learned. We are learning to protect ourselves. We are learning to look out into the cosmos and see not only the threats, but also the opportunities. We are learning to ask the big questions. That is a journey worth taking, and the path ahead is clear. We must continue to watch. We must continue to learn. We must continue to prepare. Part 11. The Path Ahead. The path ahead is one of continued vigilance and discovery. We do not yet know everything that lurks in the darkness between worlds. We are still mapping our own solar neighborhood, but the work is underway. In 2027, NASA plans to launch the NEO Surveyor mission, an infrared space telescope designed specifically to detect near-Earth objects that are hidden by the sun's glare. This mission will fill the gap in our current detection capabilities. It will see what we cannot see from the ground. It will find objects that have been hiding in the sunlight. The European Space Agency is developing similar missions, and there is growing international cooperation on planetary defense. The goal is not to eliminate the threat. We cannot do that. The goal is to reduce the uncertainty, to know what is out there, to be prepared if something is headed our way. This is a long-term project. It will take decades. It will require global coordination and sustained investment. But it is a project worthy of our attention, because the stakes are nothing less than the survival of our civilization. Let's consider what a comprehensive planetary defense system might look like. It would include a network of telescopes, both ground-based and space-based, to detect near-Earth objects. It would include a fleet of spacecraft ready to intercept any object that poses a threat. It would include international agreements on how to respond to a potential impact. And it would include public education and preparedness programs. This is not an impossible vision. The technology exists or is being developed. The challenge is political and financial. But the history of human achievement suggests that we are capable of remarkable things when we choose to act. We went to the moon in less than a decade. We built the International Space Station. We mapped the human genome. We can build a planetary defense system if we decide to. The question is whether we will decide to act before it is too late. And yet, as we prepare for the worst, we must also remember something else, something that gives this story its deepest meaning. Part 12. The Quiet Miracle. And yet, there is another way of looking at all of this. Consider the improbable chain of events that has allowed us to be here at all. Our planet sits in a narrow habitable zone, just the right distance from a stable star. If we were any closer, the oceans would boil. If we were any farther, they would freeze. We are in the Goldilocks zone, not too hot, not too cold. Our atmosphere provides protection from cosmic radiation and maintains a temperature range that allows liquid water. It is like a blanket, keeping us warm and safe. Our magnetic field shields us from the solar wind. It deflects charged particles that would otherwise strip away our atmosphere. It protects us from the very thing that destroys dead worlds. And, against all odds, life emerged. Single-celled organisms evolved into complex plants and animals, and eventually, a species developed the capacity to contemplate its own existence. That is us. We are the first species on this planet that can see the threat coming. We are the first species that can do something about it. That is a remarkable gift. We have been given the responsibility of planetary stewardship, not because we are entitled to it, but because we are capable of it. And that is a profound thing to carry. Let's reflect on the improbability of our existence. The universe is about 13.8 billion years old. Earth is about 4.5 billion years old. Life on Earth has existed for about 3.5 billion years. In that vast span of time, countless species have lived and died. Most of them left no trace. Only a fraction of them are preserved in the fossil record. And yet, here we are. We are the descendants of a long line of survivors. Our ancestors endured ice ages, volcanic eruptions, and asteroid impacts. They survived because they adapted. They survived because they cooperated. That is our legacy. We are the inheritors of a resilience that stretches back billions of years. And we are also the first species that can choose to protect that legacy. We are the first species that can look up at the sky and see not only the stars, but also the threats. We are the first species that can do something about them. That is a quiet miracle. It is a reason for hope. So, as we drift to the end of this journey, take a moment to pause. Consider the objects that have passed by us in recent years, the ones that came closer than the moon, closer than our satellites, closer than we sometimes realize. Consider the Tunguska event, the Chelyabinsk meteor, and the scars left behind by ancient impacts. Consider the dinosaurs, who had no warning and no defense against what came from the sky. And then consider the present moment. We are alive. We are aware. We are learning. The sky is not empty. It is full of motion, full of history, full of mystery. We are not helpless. We are not alone in our small corner of the universe, not because there is someone else out there, but because we are part of something larger than ourselves. We are part of the cosmos. And that is worth pausing to appreciate. Take one more slow, deep breath. Let the story settle. The night sky has always been there, long before we looked up at it, and it will be there long after we are gone. But right now, at this moment, You are here, on this planet, under this sky, capable of wonder. And that, perhaps, is the greatest near miss of all. Thank you for drifting with us through this journey. If this story sparked something in you, curiosity, reflection, a quiet sense of awe, consider subscribing to Calm Cosmic Drift. We are building a community for those who find peace in the vast questions, who seek understanding in the silence, and who appreciate the extraordinary nature of ordinary existence. Stay curious, stay calm, and let the cosmos continue to gently carry you. Until next time, drift well.